Welcome to part 3 of our series on endpoint monitoring. Last time we talked about what are endpoint regressions. Now let's take a look at the endpoint regression issue in more detail. Let's open this issue in Sentry to get more information on this regression issue. At the very top, the issue tells us our /API/Pokemon endpoint's P95 duration has increased from less than 5 seconds to almost 9 seconds, as well as the time when Sentry thinks this regression happened. Next, we see this time series showing the P95 duration of the endpoint, and we can see that there was a sharp increase around the approximate start time mentioned earlier. On the side, we also have a throughput chart. It seems that the throughput to this endpoint was fairly constant during this period, so we can likely rule out an increase in traffic to be the cause of the regression. Next, we have a list of potential causes. We see that the HTTP client span to /API/v2/Pokemon has not changed much in duration, while the other spans increased from 0 milliseconds to a few hundred milliseconds. This indicates that there were new spans that were added after the regression, and can be confirmed by switching over to the throughput view. This tells us that some new work or spans were added to the endpoint. Taking a look at the compare events, we can see that in the regressed events, there are significantly more spans when compared to the baseline event. Examining these two events side by side, we notice two things. One, there are nearly twice the number of spans in the regressed event, and two, the spans are fetching the Pokemon data sequentially. From this, we can draw some conclusions. One, our change to increase the number of Pokemons on the index page is causing additional fetches for more Pokemon. And two, the fetches are happening sequentially, which means that the performance of the endpoint will scale linearly to the number of Pokemon we display.